We are going to talk about equivalent studies. I'll try to make it very simple. Kant's presentation was very excellent, and he has covered this time a lot more newer methods. We need to go back and read the slides again. Now, I wanted to throw this problem to you, and you need to tell me the null hypothesis, and how do we go about doing this? Let me explain the study. This was done in a place in Karnataka. That this is very difficult to get psychiatrists to go and work in the community to treat psychiatric morbidities. Then someone said from the ministry, so it would be better if you could train community health workers. Please remember, community health workers who could be trained to treat psychiatric morbidities. Okay. And maybe at this level, I can see whether anybody is asking some questions. Anybody there? Any questions at this level on alpha error, beta error, and something like that? Okay, no questions. Okay, we'll go to the slide, current slide now. Now this is, so therefore this is, so 10 villages were taken, and the patients from this area were randomly allocated to community health workers or psychiatrists. So randomly allocated. Please remember, this is a randomized control trial. Now I wanted you to tell me what is a null hypothesis in the studies. How do I state my null hypothesis? Community health workers are as good as psychiatrists in treating psychiatric morbidities. Community health workers received 6 months of training. This is your null hypothesis. What is alternative hypothesis? The psychiatrists are better than the community health workers. So you have two statements. That is how this group started this trial. And I'm going to introduce the next slide, just data. This is the data. 35 patients were allocated to community health workers, and 35 were allocated to psychiatrists. And this is the data. The cure rate in psychiatrists was 63%. Yeah, 63%. And in the community health worker was 40%. So the psychiatrists are 23% better. Okay, so 23% better. But if you look at the p-value, it is not statistically significant. The chi-square was 2.8. Therefore, the study concluded that, there's no time to discuss about it here, and the concluded as chi-square was not statistically significant, so that they have concluded that as and an evaluation of side effects also showed no significant difference between the two groups. The study concluded that the psychiatrists were no better than community health workers in treating psychosis. So therefore, they concluded, what is a null hypothesis? Community health workers are as good as psychiatrists. Okay. And so the null hypothesis says the community health workers are as good as psychiatrists. Therefore, because they did not reject the null hypothesis, therefore they accepted the null hypothesis. Now the question comes, is it a negative study? Yes, it is a negative study. We have not shown any significant difference. The danger of the study is because they have not rejected the null hypothesis, they accepted the null hypothesis and concluded that community health workers are as good as psychiatrists. So remember, this is the worst way of taking a decision. So this is very important. So therefore, because they were not aware of equivalent study concept, how to write the null hypothesis, alternative hypothesis, how do we go about setting the design? Now, please remember that what Kant has taught you about margins, etc., that has to be organized. So, say for example, this is in pralidoxime oxide is given, a high dose pralidoxime oxide is given in the treatment of organophosphorus poisoning, which is a fertilizer, manure concept or something like that, a chemical, which is used for agricultural work. So people consume this and commit suicide. So this is a very common poisoning in and around Sri Lanka, India, Bangladesh, and so on, mostly Asia. So the current protocol 20 years ago that was that to provide them high dose polydioxime oxide called the PTAM. So the professor of medicine that observed that people who are taking a dose, high dose, it was a paid imported drug, so they have to afford the pay. You have to pay for the treatment, and some people, poor people, who are not able to pay for the treatment. The professor of medicine observed that people who could not afford to pay for the treatment were surviving more. So this was bothering him. Then he went back and looked at who has suggested high dose polydioxime oxide in the treatment of organophosphorus. So he could not find any literature because traditionally it was taught to people. So therefore, he decided to reduce the dose to low dose. Let me see what happens when you give low dose polydioxime oxide. So that is a study. Now, if I ask you how to write the null hypothesis, how to write alternative hypothesis, so very, very difficult if you sit and discuss in the classroom. Should I write the low doses, that is a new treatment which you're talking about, is as good as high dose, or still you would say high dose is better, and so on and so forth. So that is how, now, shall I conclude, shall I conceive a hypothesis? This is about mortality. So now the only way you could phrase your hypothesis is that low doses as good as high dose. I don't know, I pretend that I have no idea about non-inferiority trials. Ideally, it should be non-inferiority trial. Now, similarly, the community health workers and psychiatrists, that they did not know how to phrase the study, that ideally it is non-inferiority. You can't even equate the doctors to the community health workers, which the doctors may not like it. So, or that is a fact. So therefore, ideally, there is a potential problem for non-inferiority. Similarly, this study, let us pretend that I have no idea about non-inferiority trial. At least I wanted to see the mortality should be as high as the high dose polydioxime oxide. So therefore, it's a good example how to plan an equivalence study or a non-inferiority study. Now, so therefore, what you need to do is, I'll give you another example which I came across sometime back in some place. They wanted to study that in the note about the workshop, we have given that exercise example. A group wanted to study, especially newborn babies who was stunted and so on and so forth. The newborn babies, that they found out that because the children coming from UP and Bihar, they are very poor, they may not be able to provide WHO bottle feed. So therefore, they suggested that well-boiled cow milk can be given to these children. Their weight gain would be as good as the other side, other comparator. Now, how do you phrase this hypothesis? How do you phrase this hypothesis? I happened to read the proposal. The proposal said if there is no difference between the two arms, we'll accept that the well-boiled cow milk is as good as the other one, which is a wrong concept. Now, let us look at what is the potential scenario to say that I would go for equivalence or non-inferiority trial. The equivalence trial is, we don't do nowadays very much, but we do non-inferiority trials. So we're saying one outcome is as good as the other outcome. The standard of care is, the new treatment is as good as standard of care. If at all there is a difference, the difference is very small. That is how we decide your sample size, etc. So therefore, we need to see, many times you cannot even decide the equivalence, like community health workers and the psychiatrist. Now, I'm not sure whether you can equate well-boiled cow milk with the WHO bottle feed. Maybe you could say little inferior, therefore non-inferior, and so on. So for this is what he said, show effects of two treatments on a certain endpoint differ by more than a pre-specified amount. Okay. So right now we need to see how are we writing this null hypothesis. It's basically two one-sided tests. You write, this is how, there may not be any time to explain to you what I'm writing. By the end of the day, that when you the confidence level should cover 0 in between. That is, then you would say this is the outcomes are equal in both arms. Now we have discussed about how do you decide your delta. That is more of a consensus. It should not be too wide. So if you put a too wide or too bigger lambda delta, then your sample size will come down. Now, let me skip the bioequivalence that he spoke about 25 to 80 and 125 as a margin in industries. Still, if you look at the display of the equivalent studies, this should be this, and this is not equal because lower limit or upper limit have crossed. Here, lower limit has crossed the delta, therefore it is not equivalent. Now, this is what as statisticians you need to know when you explain to this. There are a lot of epidemiologists confusing in the issue, even in Vellore, that that the equivalent study should have a very small number, a very large number, very large number. Because that the superiority trial, you don't bring in the delta into the calculation. You deal only with the difference between the two arms. Here you are looking at, you are bringing that the equivalence margin also into the calculation. Okay. So what they see is the difference is only this. They look at only the differences is very small. Therefore, the equivalence study should need very large number. It's a misunderstood concept, but they don't know the basic mathematics. And if you look at this, the delta which you have phrased and placed should be included in the calculation. That for that this number is different as compared to what they feel as superiority trial. This is an example. Now I'm going to ask you this example. This is the equivalence limit difference has been, the delta has been already set. Now they're saying whatever we do, that we expect a small difference, that is 6 units. The delta is kept at 8 units. You do the calculation, the number is going to be 152 and 152. Now I'm going to ask you the question. This is, can I have an expected mean difference of 8 here? The question to you, please think about it. Then I'll explain to you. So equivalence limit difference in means is 8. This is your delta. Minus, let's say 8 units, minus 8 and plus 8. Now, they say that we presume that the data will give me a difference of 6 units. My question is, if the data gives me the mean of 8 units, what would I conclude? Martin, can you see this board?
Sir.
Yes.
Yes,
Yeah.
Yes, sir.
Okay. Now, this is what I said, my delta. This is minus delta. This is minus delta. And this is 0. We said this is, they have obtained the difference of 6 units. Let's say this is what they are saying. This is, they got a difference of 6 units here. 6 units. This is 8. 8 is the minus lambda. This is 6. My question is, shall we put 6 here? as the observed difference. The question is that you beat the purpose of the margin. What does it mean? Supposing, let me explain with a small example. This is, if the difference is 3 units, this is a single point estimate of the difference between the two arms. You fixed the margin as 8 units. So now we are saying that I cannot say because that 3 units falls within 8 units. So therefore it is inferior, equivalent. Do you understand my argument? What you need to do is, you need to establish the confidence interval for 3 units. Supposing this is, say for an example, 7 and this is 1. What does it mean? In the long run, the 3 units absolute difference could be as high as 7 units. This is called the lower limit of the difference. Okay. Now you see the lower limit of the difference falls within this delta, that minus delta, which you have fixed. Then only you conclude it is equivalent. So if you establish the confidence interval, it comes like this. Say for an example, this is say for an example, this is minus plus 3. Can you see this example? Let me explain this again with a big number. This is my null hypothesis value. The margin is fixed at minus 8 units. I got minus 3 units as the absolute difference. Okay. Then I establish the confidence interval for 3. It says minus 5 to plus 5. Minus 5 to plus 5. Now you look at the lower limit of that absolute difference, 5. It has not crossed my 8 units. And this 2 limits cover 0 also. Therefore, I could conclude equivalence. My question now is, if I put this as minus 8, observed difference instead of minus 3, if I put 8 units, that my confidence interval lower limit must be greater than that minus 8, maybe minus 12, and this may be, say for an example, plus 5 or whatever. So therefore, that you see, it is not just the absolute difference which you get from the data, which decides equivalence or not. It is the confidence interval of the absolute difference. That has to be established, and you see whether that falls within the upper limit of the interval. Okay. Now, do you have any questions here? What is equivalence? Let me explain. This is a very important concept. When you say, if you look at your slides, for an example, the equivalence is defined as this. This is your 0, and this is your difference. This is your delta, minus delta, plus delta. This is your difference, 0. What we are saying is that, say for an example, the confidence limit of the difference which you have obtained should cover 0 in between and also falls between the 2 limits. The delta is already fixed by you. The pre-decided delta, the equivalence margin, is fixed. In this example, it is 8 units. So minus 8 units and here plus 8 units. So end of the day, you do a study and the difference is, say for an example, minus 3 units, minus 3 units, minus 3 is here, minus 3 units. And the confidence interval is like this. So this is minus 5 units and this is plus 5 units. Now look at my data and see, this is the absolute difference is minus 3 units. And the confidence interval of -3 is -5 and +5. Does it cover 0 in between -5 and +5? Yes or no? Yes, it covers in between. So therefore, there's a scope for equivalence. Now look at the lower limit of the confidence interval. The lower limit of the confidence interval is -5. What is my minus delta? That is 8 units. So this is well within that 8 units. Therefore, I would conclude that this is equivalent. This is equivalence. Do you understand this? Say for an example, the same example, if I put a graph like this, 0, and this is my minus delta, this is my plus delta, and this is your 8 units. This is your 8 units, and this is something else I am not interested in. If your confidence interval is like this, -12 and +10. The -12 plus 10, does it cover 0 in between? Yes, it covers 0 in between. What is the lower limit of the difference? 12, it is greater than -8. So it has exceeded your delta, the margin, and therefore you would say it is not equal. So there you conclude this is not equal. Okay. So therefore, the two criteria which you need to look at, first of all, whether the lower limit or upper limit has exceeded the margins. If yes, that it is not equal. And it has to be within that margins, as well as it should cover 0 in between. This is very important. Let me give you another example. Where you see you need to tell me whether it is, this is 0, this is say 8 units, this is plus 8 units, this is you got -2 units, and this is -1, this is -4. Now what do you conclude? Raise your hand and tell me what do you conclude here? Is it equivalent?
Yes, yes.
Why do you say
Yes.
this is equal? Why do you say this is equivalent?
It doesn't cover 0.
Therefore, it is equivalent. It has to cover 0 in between. Then only you will call it as equivalent.
Equivalent.
It doesn't, when I say equivalent, it has to cover 0 in between. This does not cover 0 in between, and therefore it is not equivalent. So on the next slide, when you talk about non-inferiority, we conclude this is non-inferior, not equal, not inferior, because it has not crossed the lower limit, and it is within this margin, and therefore it is called non-inferiority design. Okay, any questions? Any questions? We are coming one by one. So there is somebody asked what is non-inferiority trial also, that will come again. And so we'll see. What do we assume? Equivalence variance. Okay. I don't know about the equivalence variance. What we call it as equivalence steady or not. So we always compare the means, not the variances. So this is okay. And we'll see, there are some questions, we'll look at it later on. We'll move on to somebody asking question. Okay, we'll move on to this is what. So we have discussed about what is the equivalence trial. The every day we say one is better than the other. There was a question, what is superiority trials? If we say one is better than the other, we don't specify any margin. Say for an example, the pralidime oxide or any study where the mortality is 15%. And you wanted to bring in another arm and you say the mortality should be 10%. So the 10% is much lower than 15%. This is called superiority trial. One is better than the other. The new intervention reduces the mortality by 5%. The 5% is considered as an important value, that is a difference. In order to detect that 5% is statistically significant, given the variability, then how many sample size I should study? There is no question about equivalence, non-inferiority, etc. here. Just how much is the difference? If the difference is a clinically important difference, how many subjects should I study in each arm? That is called a superiority trial. This is what every day we do. What people do, as I said, when you don't find the 5% is not significantly different, they say the low dose is as good as a high dose, or the new treatment is as good as the older treatment, which is not correct. So this is very important. So you have to design a study for equivalence, if that is your question. So therefore, you cannot have the difference which you get as the equivalence margin, because there is a confidence interval which will have a lower limit. It already is going to exceed that. You are sitting on the top of the margin, which the sample size cannot be calculated. Okay, this is what I explained to you. This is for the proportions. Please remember, this is the formula. This is for the proportions we have explained. And this is for the bioequivalence studies. I'm not going to go into the details. Don't worry about it. So you can go through the slides. Coming to non-inferiority studies, I'll take another 10 minutes and I will show you some literature examples. Non-inferiority studies to show effect of a new treatment on certain endpoint is no worse than that of an existing treatment. What is the criteria we should have for non-inferiority trials? The first criteria for non-inferiority trial is you should accept one is expected to be inferior. Please remember, this is one is expected to be inferior. Community health workers are expected to be inferior to psychiatrists. This is a situation I can do non-inferiority trial. What we are saying is, I know they are inferior, but not so much inferior. That is where when you say so much inferior, you bring in a margin to it. As long as the difference is within this margin, I am happy to accept them as non-inferior. If they exceeded that margin, then they are inferior. Okay, this is a very important concept. After two intervention, one has to be inferior. The cow milk, well-boiled cow milk, is expected to be inferior, and therefore is a good situation where you can do non-inferiority trial. What is the advantage of doing non-inferiority trial? The non-inferiority trial will allow you to show equivalence, will allow you to show superiority. Unfortunately, when you do a superiority trial, you cannot show equivalence. Please remember that the community health workers and psychiatrists, you cannot say they are equivalents. The philosophy doesn't allow. So you can go from non-inferiority equivalence to superiority, but not the other way around. Okay. Now, this is how to write. So in the interest of time, let us skip this one and see. What does it say? In simple language, we said that we cannot accept the null hypothesis. We cannot accept the null hypothesis. That is not correct. What do you conclude as it stands? There is no evidence to conclude he is guilty. So there is no evidence to reject the null hypothesis. That is all you do. But here what we are saying is the difference is greater than the delta. That means the null hypothesis says, I assume that the new intervention is inferior. Then when you reject the null hypothesis, then it becomes non-inferior. Whether the way we write, is it correct or not, that is different. That is how the whole scientific community is moving along. You assume this is inferior, reject the null hypothesis, therefore you conclude not inferior. So you set the not inferior difference here, 10 units. Please remember here we presume that according to the understanding, they are nearly equal. Therefore, we put the difference as 0. This is a very accepted way of calculating sample size. You don't look for the difference and put it. In the absence of any data, you can put there is no difference. You specify only the margin. If the margin is very wide, the number will be less. If margin is very low, the number will be more. And you need variability data. One norm variability is enough for you. You may not, that is a standard of care. Calculate the sample size. Again, this is the same 95% confidence interval if you look at, because this is completely one-sided. So therefore, you take one side, the lower side limit, because a priori is one is inferior. One treatment arm is inferior. Now, again, please remember that we are bringing in the lambda, the non-inferiority margin here. That is the deciding point for sample size. This is often forgotten or not known to epidemiologists. They create a confusion. So therefore, you have standard treatment arm, proportion in the test treatment arm, the difference is same. Sorry, the events are same and the difference is 0. But they have put 20% as a non-inferiority margin. Okay. This is 20% is a non-inferiority margin, and alpha error, beta error, and decide your sample size. So if you put same event rate, that is accepted. Please remember that same event rate is accepted. This will give you conservatively a decent number, and don't put any different values here. That will shoot your number. This is internationally accepted way of calculating numbers, and therefore the difference is 0. Non-inferiority margin is this, and you calculate your sample size. Okay, this is around something small number. So now I don't know whether you people have laptop and you can sit and do some calculation and see whether you have understood this concept. This is 2 interventions, muscle soreness. Okay, there are 65% of patients in each group, and the event rate for the newer treatment is 12.5%, and the reference treatment is 10.8%, and there is a margin of 10%. Now I'm going to, what is the question if you have? If no pain is the outcome, the newer treatment had 12.5%, and the reference treatment had 10.8%. Okay, now the question is whether the difference between the two arms is likely to fall within the non-inferiority margin of minus 10%. So how do I know? I need to simply establish the confidence interval for the 2 event rates. So, and then decide. I'll do one example that, okay, sorry, equivalent, non-inferior or equivalence. In this case, it is equivalence. Now, this is, you can do this exercise. This is a paper which got it published in New England Journal of Medicine. This is the sample size calculation. I'm going on repeating is one concept called that there are 2 arms. One arm received aerosolized vaccine through the nasal route. The other group received vaccine through the subcutaneous route, the bloodstream. So the outcome was measured after 91 days, seropositive children. So they put the non-inferiority margin of 5%. Why non-inferiority? Because the aerosolized, you waste a lot of vaccine because you just push the vaccine in the aerosolized form, that it goes waste. It goes outside the nostril, and therefore we decided to have non-inferiority design with the non-inferiority margin of 5%. Now, so do you have any other data that 90% of the children in each group would be seropositive? That is how we assume the sample size calculation. You have only one event rate, and both the groups are going to have 90% zero positivity rate. So this is very important. That will give you a conservatively lower number. And the margin is fixed. The rest is very simple. So this is, if you put this data, then it will tell you that sample of 800 children per group, and 90% power, it is more, and 20% dropout, that it gives you 1,000 subjects in each arm. It is very simple. People, if they understand that, they can easily do it by themselves manually. Okay. So this is all the margin. End of the study, now you need to look at this data. This is your margin, minus 5% they have said. The per protocol, do you remember Kant Morning said for non-inferiority design, you have to use per protocol approach, not intention to treat approach. And now, where is the lower limit? The lower limit of the difference is here. It is falling away from the non-inferiority margin. It's a completely inferior study. The newer treatment, aerosolized vaccine, is inferior to the bloodstream way of the subcutaneous route. Now, I wanted to ask you the question. Now, if I put the margin to 10%, so for example, had we decided 10% is a non-inferiority margin, what shall we conclude? Is it still not inferior or inferior? The lower limit is still away from the 10%, therefore still it is not inferior. Maybe at 15% you could conclude inferior, not inferior. But 10% and 15%, 5%, it is definitely inferior. The question is it okay to have 15% as non-inferior? It is up to the reader to decide. Okay, so 90%, can you have a 15% as non-inferiority margin? So this is still accepted. It is a good data. It's very expensive study. So.